Hello everyone. This is regarding the production order quantity model that we have discussed in the class. So for those of you who are interested to understand about how this particular formula of Q star is equal to under root 2s lambda by h into 1 minus lambda by mu came up, this particular video is a demonstration of that. So I'll quickly go through how we got that particular thing, right? So let's try to understand that. Now, as we had discussed in the uh, class, economic order quantity is the quantity that minimizes the cost, right? Now, in the traditional economic order quantity, we had made an assumptions, five major assumptions, starting with demand and lead time being constant, then receipt of inventory being instantaneous, then quantity discounts not being applicable, and stockouts, right? So as part of the relaxing the assumptions, we looked at the quantity discount model in the class. Now, if you look at the third assumption, it assumes that the receipt of inventory is instantaneous. What we have discussed in the class is that whenever the receipt of inventory is instantaneous, the diagram, the inventory buildup diagram indicates that particular thing with a vertical line, right? Now, when the inventory receipt is not instantaneous, then it will be a slanted line, which is what we are seeing over here in the production order quantity model. It is also referred to as a POQ model, where we are seeing that the receipt of inventory is not instantaneous, and that is represented by this particular slanted line. And that's what we are going to discuss about, right? What exactly is happening over here and what is this? Now, assume that the production rate, that is the rate at which things are being produced, as it is saying, it's a production order quantity model. Think of this like how production in general happens in any particular organization. Now, let's say there is one particular process which is producing something which feeds into another process. Now, the assumption that we are making over here is that as the products get produced over here, right, immediately this particular let's say station B is consuming them. That means there is a rate of production which is happening at A and the rate of consumption which is happening at B. Right. So let's assume that the rate of production which is happening at A is mu, right? And the rate of consumption which is happening at B is lambda. Now, if you look at this, the rate of production is like a service rate. Now, as we have discussed in queuing theory, mu is the service rate, that is the rate at which production or the production service is being provided. Now, lambda, on the other hand, is the rate at which the consumption is happening. That is, how many units at a time can B take this particular thing, which is almost like the demand. And the way we had assumed in the service system, that is queuing system, is that mu is always greater than lambda. Now here also, let's try to understand that. If the demand, the rate at which the demand is, units are being demanded by part B or the station B is more than what is produced at A, then you will never be able to fulfill the demand, right? You will always have a backlog. On the other hand, if you keep continuously producing at A, that is mu is always greater than lambda, then what will happen is, let's say, for example, you are producing 10 units per hour over here, and here there is a 6 units per hour consumption. Every hour, there is an excess of 4. Now, that means that every hour, there is 4 units that are getting added. And if you are looking at a 8-hour shift, that is 32 units that are excess added for throughout the time. Now, that means that it does not make sense for us to keep continuously producing that, because there is an excess inventory that we are creating. There is a holding cost associated with that. To avoid that particular thing, what we are going to do is, in this particular case, as you can see, this is not like an equilateral triangle or an isosceles triangle. It's a scalene triangle. That means there is a portion of this particular thing which is represented by this red line, and there is a portion which is represented by this blue line, which has different things that are happening. In the part which is represented by the red line, as is given over here, there is both production and consumption happening over here. right? So both production and consumption are happening over here, right? So that means that in this particular case, I'm continuously producing, and at the same rate, B is consuming that, right? On the other hand, if you look at this blue part, what is happening over here is, to avoid not having a lot of glut, that is a lot of inventory, we are stopping production after a certain point in time. Now, what is the time for which you produce that? Let's assume that that is T, right? So you're producing up to T. And the next part is where there is only consumption. That means here you have mu as well as lambda that is operating, and here there is only lambda that is operating. Now, if I'm producing at the rate of mu and the consumption is happening at the rate of lambda, obviously the rate at which this particular thing is increasing is going to be mu minus lambda. That is, if I'm producing 10 units per hour for, let's say, 2 hours, in the first hour, and 6 units per hour is being consumed by B, the first hour, 4 units are getting added, another hour, another 4 units are getting added. Now, how is that I'm getting that? 10 minus 6, which is nothing but mu minus lambda. And that is the rate at which this is increasing. Now so imagine if I'm operating this for T period of time. Now, what will be the total amount of inventory that is getting added over here? So let's take this example, right? So I'm producing at the rate of 10 per hour and I'm consuming at the rate of 6 per hour. At the end of the first hour, you will see that mu minus lambda, 4 units are getting added. Now, at the end of the second hour, another 4 units get added over here. That means at the end of the 2 hours, I'm having 8 units that I'm getting added, which is nothing but 10 minus 6 multiplied by 2. Now, what is 10? 10 is mu, 6 is lambda. This is multiplied by 2. 2 is nothing but the time for which this is operating. So that is P. So that means the maximum height that this particular thing will ever reach is, maximum inventory that we are going to reach is mu minus lambda into T. Okay. Now, what is this T? Let's try to understand that. How do we get that? Now, this mu minus lambda into T is what we are getting over here. Now, how much is that we want to produce? What is our intent we want to produce? And that is what we are trying to identify, which is production order quantity, right? So this is EOQ or POQ is the quantity that we want to produce. And that particular quantity is nothing but Q, right? So that means, what is the rate at which we are producing? Mu is the rate at which we are producing, and we are producing for a time period of T. Mu into T should be the amount that we are producing, which is nothing but Q, right? Mu into T is equal to Q. If mu into T is equal to Q, then what will happen to T? T is nothing but Q by mu. Now substitute this T in this particular part, which is the maximum inventory. This will become mu minus lambda into Q by mu, right? So this is 1 minus lambda by mu into Q, right? Now, if you understand carefully what is happening in this particular formula, how is it different from a traditional EOQ? A traditional EOQ is under root 2s lambda by h. And lambda, you can look at it as lambda, you can look at it as D. Lambda or D is the same. It's the annual demand rate, which is what this EOQ is. And what is the diagram for this particular thing? It looks like this. And the maximum height that it reaches over here is Q, right? And what is the average inventory that we got over here? It is Q by 2. The same way, if you look at this particular triangle, the maximum inventory that we have got is this. Now, what is the corresponding inventory that you will get over here? The average inventory. Average inventory is just going to be 1 minus lambda by mu into q by 2. And the only difference between this and this is here, the maximum height is 1 minus lambda by mu q. Here it is just q. And that's the reason why you will see the difference over here. Right? So the difference that you see in this particular formula is that the denominator, which is taking care of the h in now, why is this multiplied by h not at the top? If you think about it, what was the average inventory carrying cost that we got there in economic order quantity? It was HQ by 2. Now here, because it is average inventory, here is 1 minus lambda by mu into q by 2. This also becomes h into 1 minus lambda by mu q by 2. This is the average inventory cost. Now, because this is multiplied by h, and this goes into the denominator over here, that's the reason why this looks like this, right? So production order quantity model is an extension of the economic order quantity model where only the third assumption is broken. Not the demand being constant, not lead time being constant. They are both constant. Even quantity discounts are not applicable. The only thing that we're breaking over here is the third assumption. So this is one of the extension that is famous in the economic order quantity model. I hope you understand this. If you don't, try to go through this video one more time, as well as look at the textbook. That should give you more clarity. Thank you.